And welcome again. We have another problem at our screen that says a loop made of inextensible wire, that might be a thread, and it is massless, is attached to a frame. Yeah, the frame is outside. It's attached to a frame and shown in the figure and dipped into a soap solution by holding the frame. Okay, fine. That means nothing. Everything is at ease in normal process, and so we dipped a wire loop into a soap solution, and if the membrane in the loop is punctured, try with a needle. The loop will stretch into a circle. That's right, it will stretch out and it will take a shape of circle because we know why, due to the surface tension. What force is generated in the wire if the radius of the circle is 1 centimeter and the surface tension of the solution is 0.03 Newton per meter? That's all right. So there are all things in order. We don't need any other information. So to solve this problem, let us mentally break the wire loop into pieces of a small length. How? I'm showing you. Take a very small piece of wire anywhere, wire loop anywhere, and I'm going to show you in my picture like this. And this is a small, very small. That means this angle is theta, beta, anything. And this beta is quite a small. Yeah. And this length is something ds or delta s. And this tension is like in this manner, we all know. And we all know that we will discuss the rest. What I did, I showed you what I did. And thread is in equilibrium. So the tension generated in it is going to be balanced by the force of surface tension. Yeah. And the force of surface tension will be, of course, on this small section in this direction, normal to this, everywhere. This is another example, not like previous one. This is something else. And you know what to do now. This angle is beta, how you can see yourself. And this is t sine beta. And you can see here t cos beta gets cancelled out. And you can get the force towards the center of the wire loop as 2t sine beta. And the forces of surface tension is simply, their resultant will be in this direction. You can see the symmetry. And this is going to be, was it a soap bubble? Oh yes, soap solution, soap bubble. So there will be two layers. So I'm going to write it twice, sigma, and this length delta s. And delta s is nothing but 2 sigma, and this radius I don't know. And it's alright. I will see what can I do. And the next statement you are going to write for the equilibrium of the thread, of the part of the thread, as 2t sine beta will be equal to 2 sigma delta s. And sine beta is quite small, so you can write it here 2t beta, and that will be twice sigma. Delta s you can write, just put the radius here, yeah, as r, so you can write here r 2r beta, r multiplied by 2 beta, and no, you can do one thing, you can get the tension simply as it will become 2 alpha r. So we needed this radius. Was it given in the problem? Yes, it was given, and the value of sigma is also given. So this was a simple problem, we solved it. You can use the energy method as well, and I can do with one more method, but I don't remember it like now. So this problem is solved. Thank you for watching.